Note for video: my videos are fact-based, made for curious minds and knowledge lovers. If you spot any mistakes, please comment. It helps me improve and keeps the facts accurate. Some may love cinematic visuals, but my focus is purely educational and informative. And don't forget to subscribe my channel. Let's start the video. What if I told you there's a color your eyes have never seen? Not because it's tucked away in some deep sea creature or a distant nebula, but because your brain literally wasn't built to process it. For our entire existence, we've been living with a biological lock on our vision, a built-in limit that defines the edges of our reality. But what if that lock could be picked? Recently, researchers did just that. They unlocked a new, forbidden, color perception called OLO, and it's rewriting what we thought was possible for human vision. It's a hue so pure, so intense, that it makes every color you've ever seen look pale and washed out. In the initial experiment, only 5 people on Earth had ever witnessed it. This isn't a filter or a screen trick. In fact, it's a color so impossible, I can't actually show it to you. So, what does this forbidden color look like? How did scientists find a secret backdoor into the human eye? And what could its discovery mean for the future of sight? Let's get into it. The prison of perception. To understand how you find a color that shouldn't exist, you first need to get how your eyes work. It all starts with the electromagnetic spectrum, an infinite river of information flowing all around us. We only see a tiny, almost pathetic sliver of it, the visible spectrum. Your eyes are the gatekeepers. On the back wall of your retina, you have millions of photoreceptor cells called cones. Think of them as 3 microscopic sensor teams, each reporting for duty. You have L cones for long wavelengths, reds and oranges. You have S cones for short wavelengths, blues and violets. And in the middle, you have M cones for medium wavelengths, the greens. Your brain gets signals from these 3 teams and mixes them to paint your entire visual world. Every sunrise, every forest, every screen you've ever looked at, it's all a custom blend of red, green, and blue signals. But here's the catch, the biological rule that, until now, has been unbreakable. The M cones, the green sensing team, are never alone. Their sensitivity range overlaps almost perfectly with the L cones and the S cones. This means there is no single wavelength of light in the universe, no laser pointer, no natural phenomenon, that can stimulate only your green sensing cones. Every time you see green, your M cones are firing right alongside your red or blue cones. You never get a pure green signal. It's always blended, always a little bit tainted with another input. Imagine our piano where the G key is physically fused to the keys next to it. You can't play a pure G note. You can only play a chord that includes G. For all of human history, our brains have only heard these visual chords. We had no idea what a pure, isolated, M signal would even look like. It was a sensory experience that was, for all intents and purposes, forbidden. But that just made some scientists wonder, what if we could break that fusion apart? What if we could finally play that one impossible note? Hacking the human eye. What if you could bypass nature's hardwiring and send a signal to the brain it has never, ever received before? That was the question that obsessed a team of researchers at the University of California, Berkeley, and the University of Washington. Led by figures like Professor Ren Ng, they laid out a plan to stage a biological jailbreak. Their groundbreaking work, published in the journal Science Advances, wasn't about finding new light. It was about creating a new type of perception. The key wasn't out in the world, it was inside the eye. They knew if they could isolate the M cones, they could unlock something totally new. The problem is, you can't just shine a green light at someone and hope for the best. The other cones will fire too. You need a tool with almost impossible precision. So, they built one. They called it Oz, The name is a nod to the wonderful Wizard of Oz, a story about visitors to an emerald city so brilliant they had to wear green-tinted glasses. In the book, it was a trick. But the Berkeley team's Oz was the real deal, a machine designed to reveal a color more brilliant than anything in the natural world. The Oz system works through a two-step process that feels like it's straight out of science fiction. First, it has to create a map. Every person's retina has a unique pattern of S, M, and L cones, like a fingerprint of light-sensing cells. Using a sophisticated adaptive optics system developed with researchers at the University of Washington, Oz scans a patch of a subject's retina, identifies the precise location of thousands of individual cones, and tags each one as red, blue, or green sensitive. It creates a personalized GPS of your own visual hardware. Once the map is loaded, the hack begins. Oz aims a single, hair-thin laser at the subject's eye, rapidly scanning the mapped area. But it doesn't stay on. Using the cone map as a guide, the system fires unimaginably small and perfectly targeted microdoses of light only when the laser is pointing directly at an M cone. The instant it passes over an S or L cone, it shuts off. It does this thousands of times a second, essentially playing the retina like an instrument, but activating only one specific type of key. For the first time in history, a human brain was about to receive a pure, unadulterated signal from only the M cones. They had picked the lock on perception. The question was, what was on the other side? What the forbidden looks like. The experiment was set. In the initial study, 5 people, mostly scientists on the research team, including Professor NG himself, sat down and peered into the Oz device. They became the first human beings to ever consciously witness this new perception. So what did they see? What does the impossible look like? Their descriptions were immediate and unanimous. A blue-green of unprecedented saturation, others called it a profoundly saturated teal, or a peacock green, but words didn't really do it justice. Professor NG described the experience as simply jaw-dropping, explaining it was a color more saturated than any color that you can see in the real world. The idea of saturation is key. Think of it as color intensity. Professor NG gave an analogy. Let's say you go around your whole life and you see only pink, baby pink, a pastel pink. And then one day you go to the office and someone's wearing a shirt, and it's the most intense pink you've ever seen, and they say it's a new color and we call it red. That's the leap in experience from the most saturated teal you can find in nature to the raw, direct experience of Olo. Participants said even the most vibrant colors in the real world looked pale by comparison, but how could they prove this wasn't just a psychological trick? They devised a brilliant test. Participants were shown Olo, and next to it, a display where they could create the most saturated natural color possible. A pure, monochromatic teal from a standard laser. They were asked to match the two. It was impossible. The natural laser teal looked washed out next to Olo. So, the scientists added a control. They gave participants a dial that could add white light to Olo, desaturating it. Only by dialing in a significant amount of white light could they get Olo to look as pale as the most saturated color nature can produce. This was the smoking gun, undeniable proof that Olo existed on a plane of saturation beyond our normal visual gamut. The researchers needed a name. They turned to the language of vision science. In the LMS color space, which represents the firing of the L, M, and S cones, a pure M cone signal is represented by the coordinates 0, 1, 0. In Leet speak, that 010 spells Olo, a name born from the pure poetry of code. The great debate. Okay, but whenever a discovery claims to break the fundamental rules of biology, it's going to be met with some serious scrutiny. The story of Olo sounds incredible, and the scientific community is built on rigorous debate, not blind faith. So, is Olo truly a new color? The answer is complicated, and it sparked a fascinating debate. On one side, the Berkeley team and others argue that yes, this is a new frontier. A signal that the brain has never processed from nature is, by definition, a new experience. It expands the space of human perception. But on the other side, you have respected experts like Professor John Barber from City Street, George's, University of London. While he agrees the Oz technology is a massive, technological feat, he argues that calling OLO a new color is open to argument. His point is that the participants weren't seeing something totally alien, they were seeing a shade of blue-green. What was different was its intensity. He argues, OLO isn't a fundamentally new color, but a more saturated green, made possible only by artificial stimulation. The debate really boils down to a philosophical question: what makes a color new? Is it a completely different hue? Or can a familiar hue, when seen at an intensity that nature forbids, become something new in itself? Is that fire engine red just a more intense baby pink, or is it a fundamentally different experience? There's no easy answer, and both sides have a point. The technology is new, and the language to describe what it unlocks is still being formed. But whether you call OLO a new color or a new tier of color, one fact is unshakable: it's a visual sensation that no human brain, in millions of years of evolution, has ever experienced from the natural world. It is the sound of a single, pure note, finally played after an eternity of hearing only chords. If your mind is reeling with the idea that we can hack our own eyes to see the impossible, do me a favor and hit that like button. It really helps the channel out. And if you're new here, make sure you subscribe and turn on notifications, because you won't want to miss where science takes us next. The future is sight, so why does any of this matter? Beyond giving a few scientists a mind-bending experience, what's the point of OLO? Is this just a cool party trick locked in a lab? The answer is a resounding no. The discovery of OLO and the Oz technology isn't an endpoint. It's a doorway into a future where we can rewrite the rules of human sight. The most immediate application is in studying and potentially treating color blindness. Millions of people have forms of red-green color blindness because their L or M cones aren't functioning correctly. The Oz technology offers a radical new tool. For the first time, researchers can precisely target and stimulate the remaining cones to understand exactly how their brains are processing color. In the future, this tech could potentially be used to feed the brain the missing color signals. But it gets even wilder. Scientists are already exploring if Oz could be used to induce a form of human supervision. Most humans are trichromates, with our 3 cone types. But some animals, and a tiny fraction of human women, are tetrachromats. They have a 4th type of cone, allowing them to see distinctions in color that are completely invisible to the rest of us. With the Oz system, researchers believe they could simulate the input of a 4th cone type, giving a normal person a temporary, controlled glimpse into the world of tetrachromacy. Beyond that, this technology is a revolutionary new tool for neuroscience. We can finally ask the brain questions we could never ask before. How does it build our reality from raw data? How adaptable is our perception? If you feed the brain a signal it has never encountered, how does it learn to interpret it? We can now study eye diseases at the level of individual cells and potentially create hyper-realistic virtual and augmented reality displays that don't just trick your eyes, they communicate directly with your retina. OLO isn't just a color. It's a proof of concept. It proves that the reality we perceive isn't the only one available to us. Our biology isn't a destiny, it's just the default setting. And for the first time, we have the tools to start exploring the others. We spend our entire lives inside a sensory bubble, defined by the limits of our eyes and brains. We take for granted that what we see is what's there. But OLO shatters that assumption. It's a pinprick in the fabric of our reality, a crack that lets in light from a world beyond our natural senses. The fact that I can't show you OLO on this screen, that it can't be mixed with paint or printed on paper, is the entire point. It can only exist as a direct conversation between technology and your retina. It proves that things are hidden in plain sight, not because they're small or far away, but because we just don't have the biological hardware to see them. And that leaves us with a final, awe-inspiring question. What other forbidden sensations, what other olos of sound, touch, and taste are locked away in our own biology, just waiting for the right key? Let me know what you think in the comments. Thanks for watching, and stay curious.